So BS Ed Mathematics students and to Ma'am Pamela Bation, good afternoon. We are the 8 presenters, and the topic at hand that will be discussed for today or for this moment is a sampling of classroom assessment strategies and tasks. By the way, I am Kent Bral A. Pino, and together with me is my co-presenter, Jesame Zerueta. So before we start everything else and start the presentation, let me share this quote or saying by Neil deGrasse Tyson. So he said, education is not about going to school and earning a good grades, but it is about learning how to think and to solve problems. But the question is, do the students really internalize the quote or saying? Do they actually aim for learning how to think and learning how to solve problems? The sad reality is that they are not aiming the same thing. They're aiming for good grades and aiming for that spot, the title, and the honor title. And they'll do everything, whatever it takes, even if it means cheating. So what that is the sad reality about education for today, in today's generation. So that's why it is essential to develop effective assessment strategies so that before our students will be engaged in assessments that are recorded, they are monitored and their progress and their learning is monitored through small assessment strategies or formative assessment strategies that will aid their learning and that will enhance their learning before taking exams or recorded assessments. So, in our presentation, we have the following context. So we have the introduction, the learning progression oriented assessment, the SPUR approach, the practical worksheets, utilization of rubrics, and some additional contents. So let us move forward. So we have the introduction. So classroom assessment strategies or techniques are brief assessments of students' learning that can be used in the classroom to gather data on their progress prior to higher risk exams or assignments with grades. So kining classroom assessment strategies is kind of sort of a formative assessment since these are small assessments that will aid the students' learning, that will enhance the students' learning, and that teachers themselves will be able to identify the strengths and weaknesses and um, boosting their learning in that specific course of subject. So, with the help of CATs, a teacher can actively participate in their students' education by using their input to modify the way that material is taught or how the classroom is run right away. So, as what I have said earlier, since the teachers themselves already identify the strengths and weaknesses, so they might be able to identify what are the things that should be developed, what are the things that should be enhanced, and what are the things that should be modified, or what are the things that should be altered in order to fit into the weaknesses, especially in the weaknesses side of the students. So moving forward, so additionally, CATs give students the chance to consider what they have learned, it will be easier to carry out these procedures if teachers explain to the pupils why CATs are employed in the classroom. So that this is why it is necessary to inform our students that um, there are things, not things, but assessments or activities that are employed to students, even if they are not recorded, but they are still deemed essential in developing their mastery in develop and as well as promoting the learning in a specific subject. So moving forward, let us have the assessment strategies that are proven and tested by scholars or by researchers. And the first assessment strategy we had here is the learning progression oriented assessment. So let us read. So Kim and Letter 2015 use a learning progression oriented assessment system to aid teachers in developing tasks that help students make conceptual progress in a particular content domain. Their work entails developing construct maps that are outcomes of learning progression, assessment items intended to generate the times of reasoning. In the construct maps, scoring exemplars, and then lesson plan with context that enable students to engage with the representation of mathematics. So from the word itself, or the term itself, we have the learning progression. So there is a specific progression of learning. So from this level, which starts from the basic level up to the advanced level, and that in every skill level or mastery level, there are sets of activities and learning experiences that fit to that specific level of mastery. So kung sa basic, mga simple na mga activities, mga simple na mga learning experiences ay maghatag sa bata, dapat magkaanam-anam po siya increase as the level of mastery increases. So that is the essence of learning progression-oriented assessment. So let us take this as for example. So let us have calculus for instance. So I guess everyone is already familiar with the word calculus, the term calculus. So let us have calculus for instance. Before we proceed on to the subject matter itself, it is deemed essential to first determine if the students acquire the prerequisite skills. So what are the prerequisite skills? So let's now identify. So to efficiently undertake calculus itself, which include algebra manipulation, ano man, because if you do not know how to factor, if you do not know how to engage, to do operations in algebra, well, calculus in us is not something that you should be dealing with so easily. So aside from algebra manipulation, you should also master solving algebraic equations, graphing and evaluating functions, simplifying and solving exponential and logarithmic equations, and as well as evaluating and solving trigonometric functions. So let me tell you something. Calculus, especially in when there is an integration of trigonometric functions, it is actually very difficult to do. So moving forward, we also have another example. So in natural classes, on the other hand, we can also include that learning skills in sets or set theory are deemed significant in learning the logic theory. So sa set theory, sa may kayo ang mga skills, sa prerequisite skills that should be um, mastered first. So ang imong bata na kay atong sahon, the main point here is that the teacher administers assessments that are appropriate to the current level of knowledge and skill of the students and will be upgraded over a period of time based on the weight and the scope of the teaching learning progress undergone within a specific time frame. Furthermore, the assessments are relevant and open opportunities linking to previously acquired knowledge and skills. So, sa set theory, dili lang kay mag-drawing ra kag Venn diagrams, so mag-kuan ra kag mga concepts, but you should master the logic theory. So, na logic theory, like for example, the if then statements, then kanang mag-identify po ka the commonalities of statements, something like that. So, ang pinaka-essence sa learning progression-oriented assessment is that dili kay isa lang ka concept ang imong gi-apply, but before you can proceed to learning a particular subject domain, there should be a linkage or a connection of different concepts and some content domains in order to fully understood a content domain. So for example, sa calculus, dapat nakabalo kag algebra, kabalo ka og uh, graphing function, something like that. So the second assessment strategies nga naa nato karon is the SPUR approach. So what does SPUR approach means? So the SPUR approach is an acronym formed by the words skills, which stands for S. S stands for skills. P stands for properties. U stands for uses, and R represent I stands for representations. So according to Thompson and Carr 2011 and Blair and Thompson 2012 to 2013, for any content topic, teacher might consider tasks that assess understanding of that content of the four dimensions. Typically, skills which deal with algorithm procedures, properties which deal with underlying principles, uses which focus on applications, and representations which deal with diagrams, pictures, or other visual representation of concepts. So the problem in the mathematics education for today, most of the problems in the mathematics education in today's generation is that most of the teachers only teaches the skills, often forgetting the properties, the real life application or uses, and representing the concept in visual representations. So, mo ni nakapait karon sa mathematics kay nagtudlo lang ang maestra in art in how to solve the problem, how to get the x, how to get the y, and not teaching the students unsaon siya paggamit in real life context. So, for example, kung nasa x, unsa si x ba yun na siya, pwede ba na siya magamit sa gawas sa eskwelahan, something like that. Mo na dapat unta itudlo sa mga students kaysa magtudlo lang unsa ang x and y and getting how to get the x and y values. So, this approach advocates for a multi-dimensional approach to assessing students' understanding, which was found efficient based on a curriculum work done by the University of Chicago School of Mathematics Project in USA. Why multi-dimensional man? Kay dili lang kay in sport approach, dili lang kay ang skills ang gi-assess. Gi-assess po niya kung how the students themselves will apply or will use the specific concept, the specific procedures in real life applications. Apart from that, they were also identifying what are the underlying principles nganong kana ging ana o nganong kana ang gibuhat na solusyon. So apart from that, nila pong ma-connect nila ang idea. So, like for example, maggamit siya og linear equations like x plus 3 is equal to 0. Kung sa pailain nga way nga ma-represent nga kana nga idea nga dili lang kay numbers ra, pwede man siya gamitan nato graph, pwede po nato siya gamitan og square unit, something like that. And that in spur approach is proven to be successful and efficient in some parts of the globe, specifically in the USA. So let us take this one for example. So spur approach, the skills evaluate 0.6 times 1.5. So what can you observe from that? It is simple, right? And these are the things. This is specifically what the traditional classroom does. Nag-solve na siya, nag-calculate 0.6 times 1.5. So, mount na kayong classroom kung kanarang gitulo sa teacher. But, observe the properties and uses and representations. What can you say from the properties? So, na-develop ang critical thinking sa bata. Nga, pwede din nga, magamit siya other properties. Dili kay multiplier mo siya dito. So, sa uses pod, what can you observe? Basa na ta. Find the cost of 0.6 kilos of meat costing 1.50 euros per kilo. So, from 0.6 times 1.5, the students themselves can realize that it can be applied in purchasing meat. So, say for example, nag-purchase ng 0.6 kilos of meat. And ang per kilo is will cost 1.5 euros. So, na siya specific application og maka-realize sa bata na dili lang taman ra sa eskwelahan ang kanang 0.6 times 1.5. So, napunta diri representations. So, if the figure represents 1 unit, illustrate 0.6 times 1.5. So, sa representation, from 0.6 times 1.5, ang gibuhat na sa bata is iyan ang gidraw or girepresent using visual representations. So, nanaputay another example. So, the skills. Find x. The quantity of 3x plus 1 plus 3 is equal to x plus 3. So, unsay makita nimo? Sa mga skills. So, the thing that you will only do is that find x. Wala na. So, in spur approach, napa may properties. So, what are the property that can be applied in the given equation? So, as you can observe, from this to this, we have the application of addition property of equality. And doing everything and finishing the task, you can get x by what? By applying a principle called addition property of equality. So, from the equation 3x plus 1 plus 3 is equal to x plus 3, unsa pa other uses? Pwede nimo siya imuon nga magamak ang problem. So, you can apply age problems. So, for example, John is 1 year more than thrice the age of his sister Anna. In 3 years, what will be their ages? So, if you will represent the given problem the same equation will be formed. So let's proceed to representation. So from 3x plus 1, the quantity of 3x plus 1 plus 3 is equal to x plus 3. We can also use this to represent the angles, the vertical angles. As you can see, these are vertical angles with with unknown values. So, ma-represent mo siya using the transversal line. In this transversal line, ma-represent mo siya. Since by the definition of vertical angles are always congruent. So, suppose a pair of parallel lines is cut by transversal, what are the measures of the angles with the given details? So, something like that. So, if the students solve a skill problem but represent the concept visually, what does that say about the robustness of students' understanding of what are the implications for students as teachers' instructional decisions? Thompson and Core's study led to results which asserted that students' proficiency is often different across these four dimensions, perhaps because of differential emphasis in the curriculum as well as instruction. So, ang gimin ni Thompson and Core's, so kung magamit ang spur approach, some of the students may not display the same level of mastery in a specific domain. Like for example, some students are more efficient in in demonstrating the skill domain, and some also others are more capable of doing the representation domain, and that is because teachers' approaches to teaching mathematics vary. So mostly in traditional classrooms, teachers are more into developing skills, but not on realizing or internalizing properties, or not um, letting the students realize the real life applications or uses. And some other teachers also avoid uh, students in teaching how to represent a specific concept from numbers and variables into visual representations by doing graphs, by doing concept maps, or something like that, or graphic organizers, something like that. So moving forward, we have the third. Can you read? So the third is practical worksheets. So based on the problem-solving work of Polya and Schoenfeld, the practical worksheet has students make explicit statements that indicate how they understand the problem, what plans they develop and implement in an attempt to solve the problem, what key points and detailed steps were taken at various decision points along the plan, and how they checked their solution and expanded the problem. So according to George Polya, in how to solve a problem, there are four steps. Ana si Polya nga, there are four steps. Dili kayo mag-solve ka dito. So there are things that you should do or you should comply in order to fully solve the problem. So these are the four steps in solving a problem. So the first is understand the problem. So unsay mo buhatan sa understand the problem? You will understand the problem, analyze everything. You will get what you will check what is known and what is unknown, identify what is known and what is unknown, identify what is asked, list everything that is given, and as well as interpret interpret everything that was said in the problem into expressions. Kung dili siya makaya expressions, pwede pud gamon nimo og visual representations. And understanding the problem, you can do many steps, so many methods in solving a problem. If you can do it visually, then do it. Okay, for example, in geometry, magdraw man jud ka ana. Trigonometry, magdraw man ka ana. So some problems also kay pwede ra nimo nga mga expressions lang, mga equations lang kay, especially in age problems, something like that. Second, devise a plan. What do you mean by devise a plan? Create a plan. From the given unknowns and unknowns, create a plan. How will you create a plan? based on the principles that can be applied on the problem, then create a plan, create a solution, create create a method that can somehow or that can probably solve the problem. Third, carry out the plan. So this is the step. This is the step that we will solve the problem itself. Imo na siyang solve kung sakto ba or dili. So the fourth step is look back. So look back or reflect. So kung naka-answer na ka, sakto na ba tanan? Dili. So the fourth step will allow you to look back. So check everything. Kung sakto na ba, kung unsa imong na-learn, kung ma-extend pa ba ang problem, o pwede pa ba nimo ma-connect ang problem to another problem. So, if you will solve a problem, solving a single problem is not solving the problem itself. Kaya ang problem, magpatuloy siya nga problem. Kung makasolve ka isa ka problem, dapat ka na nga problem link nimo to another problem, makasolve ka itong problem link to another problem, and solving problems is continuous. Continuous siya. Problema, hantod sa problema. So, these are the examples. So, if Alisa is thrice as old as Benny, and Benny is 3 years more than the age of Lucy, 7 years from now, how old will they become? So, given given that problem, you will, the students themselves can realize that, hala, ang mathematics di ay kadili na kay X and Y. So, mao na siya ang nakangindot sa mathematics. From the word itself, practical. So, how about we will apply mathematics into the practical world, into the real world, applying everything what we learn in mathematics in real life context. Second, modern siya. So if second example, if it takes 15 hours for an inlet to fill a water tank and 12 hours for an outlet to empty it, how long will the tank be full if both hoses, inlet and outlet, are left open? So let us try to solve this one. So if it said, solving the problem. So for example lang ha, so solve. So how will you, what specific principle in math can you apply in this problem? So we can apply the work formula. So in work formula, it states that one work is equal to rate times time. Work equals rate times time. So we can say that x is over 15. It means that one work over 15 hours. And that is for only for the inlet. And the 12 hours, we have x over 12. One work is equal to 12 hours. And that is for our outlet. So, x over 15 minus x over 12 is equal to 1. And solving the problem, kamo na ibahal. So, all in all, in practical worksheets, we will let our students realize that some problems are not actually problems in math. Kaya tanang problema sulbat gamit ang math. So, the rest will be discussed by Jessamay Zulueta. And thank you.
Now, moving forward, let's have culturally sensitive task-based interviews. Now, culturally sensitive task-based interviews are approach to interviewing that combines practical tasks with an awareness of and respect for the cultural backgrounds of the interviewers. These methods aim to create a more inclusive and equitable interviews process that allows candidates to showcase their skills and competencies in a ways that are meaningful and relevant to their cultural context. Now, let's have the utilization of rubrics. Now, according to Smith and Berry 2014, that a rubrics help students and the teachers. Now, how does rubrics help students and the teachers? Now, let's have the teachers. When teachers develop the rubrics, they get very clarified where the criteria by which learning will be assessed and so will become more focused on what to teach and against what criteria student success will be measured. Now, for the students, the criteria and performance level descriptions in rubrics help students understand what performance and criterion of performance are expected from them. Now, with this, teachers help students understand expectations and improve their performance while aiding teachers in efficient, fair, and objective grading. Additionally, rubric supports curriculum development and professional growth for educators. Now, there are four types of rubrics, and these are holistic, analytic, general, and task-specific rubrics. Now, holistic rubrics is useful for providing a quick and general assessment of complex tasks where on overall judgment are more practical, while analytic rubric is particularly useful for assignments that have multiple dimensions, such as essay, projects, presentation, and other complex tasks. Now, the difference between the holistic and analytic is that holistic rubrics is a time saving and easier to grade, while analytic rubrics it is time consuming and it is difficult to give grades. Now, where the general and the task specific rubrics is like um, holistic and analytic also. Now, provided the example of holistic and analytic rubrics among the number of alternative assessment methods that mathematics teachers can use. Writing journal apparently can be said to be the easiest assessment methods to carry out in the mathematics classroom without having a compromise significantly the teacher's formal teaching time because of its flexibility and ease of use and the benefits that can be reaped towards achieving learning outcomes. Journal writing should be um, seriously considered as having a place in the mathematics classroom. In fact, according to Core and Chan 2011, writing journal is an efficient method to assess students' honest um, experiences in the teaching learning process. Now, moving forward to a concept map. When we talk about concept map, it is a versatile tools that helps organize, visualize knowledge. They are valuable in educational settings for enhancing learning and comprehension, as well as in professional environments for planning, brainstorming, and problem solving. By clearly illustrating the relationship between the concept and the concepts, concept maps make complex information more accessible and easier to understand. Um,